So integration using trigonometric substitution. So there are three patterns that you have to look for. Okay, so first thing, if you recognize this pattern, A2 minus U2. Second pattern is if you recognize A2 plus U2. And the third pattern you're looking for is U2 minus A2. Then you will do the following substitutions. So in this case, you will set U as A times the sine of theta. Here you will set U as A times the tangent of theta. And here you will set U as A times the secant of theta. Okay, and if you do these substitutions, the integral will simplify a lot. Okay, very significantly simplified. Okay, if you use this substitution, and I'm going to give you an example to show you how this works. Okay, so example. Let's say I'm looking for the antiderivative of, so very easy one, square root of, let's say, 9 minus 4x2. Okay, so which of the three forms do you recognize?
First one.
It's A2 minus U2. Okay, the U is always the term that contains the variable. Okay, so A, in this case, A2 is 9, so A is 3, and U2 is 4x2, so U is 2x. Okay, so if you want, this is like A2, and this is like U2. Okay, so let's do my substitution. So U, which is therefore 2x, will be A, which is 3 times sine theta. Good? This is the substitution I'm going to use. So I need to find the derivative, right? So the derivative of the left is 2dx is equal to 3 cos theta d theta. Follow me? Okay, and so dx is 3 over 2 cos theta d theta. And so I'm ready to replace. Here. So it's equal to the integral of 1 over square root of 9 minus, okay, 4x2. 4x2, if I square 2x, I'm going to square this guy, I will get 9 times sine squared of theta. You understand this?
No. Can you repeat?
Yeah.
Yes.
Okay. So this here is 2x. So it's 3 sine x. So sorry, 3 sine theta squared. Right? Because this we said it was 2x. Right? It's 2x. We see it on the bottom. Okay. We said 2x is 3 sine theta. If I square both sides, 4x2 is 9 sine squared theta. And that's what I have here. I have 4x2. 4x2, so I have to put 9 sine squared theta. Questions? Times dx. So now I have to put in my dx now. What's dx? Well, I just got it here. Dx is 3 over 2 times cos of theta d theta. Would you like me to re-explain this substitution?
Yeah, sure.
Okay, so again, first step, I recognized the first pattern, okay? A2 minus U2, okay? So U2 is 4x2. It means that U is like 2x. So this will be here 2x equals A, which is 3, times sine theta, right? Okay, so this is my substitution. 2x is 3 sine theta. Now, next step, I'm going to do the derivative of both sides. 2x derivative is 2dx equals 3 cos theta d theta. And I isolate dx, that is 3 over 2 cos theta d theta. Any questions on the what's in pink here on the bottom, on the substitution? Any question there before I advance?
So I don't really understand where the 2x comes from.
What the what? I'm sorry.
The 2x.
Oh, this 2x here on the bottom?
Yeah.
Okay. So I'm going to just explain it here. So we said A2 minus U2. If I have this, then I will do U is equal, oh, there's some, I will have space, sorry. If I have A2 minus U2, then my substitution is U is equal to A sine theta. Okay. Now what do I have here? I have 9 minus 4x2. Okay, so this means that A2 is 9, so A is 3. Is that okay?
Yeah.
And then U2 is 4x2, so U is 2x. Is this good?
Yeah, thank you.
That's it. So now here I replace U is 2x, A is 3, and sine theta. That's what I have there on the bottom in pink. Any questions?
I'm good, thank you.
Okay, anybody else? Okay, I will erase this because I need space. Okay. So this is what I end up with. I end up with the integral of 1 over the square root of 9 minus 9 sine squared theta, okay, times 3 over 2 cos theta d theta, right here. Okay, this is just by replacing everything in what's in blue here. Now let's work on this integral. 1 over, so 9, I could pull it out, factor it out of the square root, it becomes 3. Square root 1 minus sine squared theta times 3 over 2 cos theta d theta. Questions? Okay, let's clean up the 3's. Let's pull out the half. Okay, and so on top I have cos theta d theta, and on the bottom, what do I have?
Also cos theta.
Very nice, right? Because 1 minus sine squared is cos squared. So I'll do one step here, extra step. So cos squared theta, right? Because 1 minus sine squared is cos squared, and square root of cos squared is cos. So these also, they vanish. So I have 1 over 2, the integral of d theta, which is just 1 over 2 times theta plus. Okay, so that's a very easy integral, as you see. Everything simplified very nicely to this. The only thing I need now is to find what theta is. And to do so, I go back to my substitution.
Wait, so is it cos theta d theta over cos power 2?
Yeah, square root of that. Square root of cos power 2. Yeah.
Okay, thank you.
Okay. Okay, so let's go back here now to 2x. My substitution was 2x is equal to 3 sine theta divided by 3. So sine theta is 2x over 3. And so theta will be the arc sine of 2x over 3. And that will be my answer. 1 over 2 arc sine of 2x over 3 plus. So let's try this one. Integral of square root of, let's take 4 minus x2 dx. Okay, so it looks very easy, but it's not. Okay, so of course, if we had an x in front, if it was x square root of 4 minus x2, we could just do a substitution. Because, right, if you do u equals 4 minus x2, the derivative will be 2x, and the x will be there. But we don't have that. So we have no choice here. Can you tell me what substitution you will use here?
So the first one,
Yeah, so which substitution will be?
u is x.
X equals to, yeah, the first one, very nice, it was, times a sine theta, right? So a is 2. So 2 sine of theta. Good? derivative dx is 2 cos theta d theta. Okay, so far it's pretty easy. Let's go here. We write so integral of square root 4 minus, so x2 is 4 sine squared times dx, which is 2 cos theta. Any questions? Integral, take out a 2 from here, right? 4 factor out of the square root becomes 2 square root of 1 minus sine squared theta times 2 cos theta d theta. And 2 times 2 is 4. And 1 minus sine squared is cos squared. Square root is cos. Cos times cos is cos squared. Any questions until here?
Could you repeat what you said a few seconds ago, sir?
So, right, is this step okay?
No, it's what you were explaining there that I didn't catch.
Okay, so what I was explaining here is just how did I get from this step to this step, the last one. So 1 minus sine squared is cos squared. The square root of cos squared is cos. And then cos times cos is cos squared.
Okay, I see. Thank
Okay.
you.
Just doing the algebra. And now I'm faced with this integral. Do you know how to do this one? How do we do this integral? We get it's even. So you have to use the identity 1 plus cos of 2 theta over 2 theta. Okay, 4 over 2 is 2. And then I'm going to do the antiderivative of 1 plus cos 2 theta. That will be theta plus the antiderivative of cos 2 theta. We get it today. Sine 2 theta over 2 and then plus. So I'm done. My integral is done at this point. Only thing I need now is to re-express everything back in terms of x. Okay, that's also a challenge.
Sir, why did the 4 become a 2 like outside of the integral?
Because it's 4 divided by 2 here. This 2 on the bottom.
Oh, okay, thank you.
Okay. So now I'm going to multiply the 2 inside. So I will get 2 theta plus sine 2 theta plus c.
Wait, sir. Sorry. Why does the cos 2 theta become sine 2 theta over 2? Can you say it
This one
again,
on the
please?
bottom here,
Yeah.
because the antiderivative of cos of 2 theta is sine 2 theta over 2. We did this morning, I think, right? We did a substitution. What should you derive to get cos 2 theta? Well, it's sine 2 theta over 2. Because if you do the chain rule here, when you derive sine 2 theta, you'll get sine 2 theta times 2.
Okay.
2 will cancel. You get it?
Mm-hmm.
Okay. There's one formula here we need to know, okay, for the identity for sine of 2 theta. Sine 2 theta and cos 2 theta. These are important identities you need to know. So sine 2 theta is 2 sine theta cos theta, and cos 2 theta is cos squared theta minus sine squared theta. So these identities you have to remember. Okay, you should have done these in high school, but if not, here I remind them for you.
Sir,
Yep.
we're only gonna be working with this tool.
Excuse me.
Like we don't need the cos 3, cos 4.
Oh, cos.
Like there's one for cos 3 data.
I don't understand. You see you want an identity for sine of 3 theta, for example?
Yeah, are we gonna be using that?
Well, it could happen,
Okay.
okay? But if you want, this is what you need to know. Cos sine of a plus b is sine a cos b plus sine b cos a. And then cos of a plus b is cos a cos b minus sine a sine b. Okay, so here are the identities. With these 4 identities, you could pretty much settle any problem, any sign of 2 theta. You could always partition the 2 theta into or 3 theta and whatever you want using the identities. Okay, we'll have a chance to encounter these situations, Jules.
Sir, sine 2 theta is equal to 2 sine theta times,
Yeah, cos theta. Yeah, on top here.
under that it's a minus.
Under that it's a minus here. Yeah. Okay, so let me rewrite now. I don't want any 2 thetas, I just want thetas here. So I have 2 theta plus, so sine 2 theta is 2 sine theta cos theta plus c. Okay, I'm going to finish with this example because it's a bit late. So the last step is to re-express. So the integration is done. Now my challenge is to re-express everything in terms of x. Okay, the question came with x. We have to send it back with x. So to do so, I'm going to go back to my substitution. Okay, so x is 2 sine theta. And so this means that sine theta is x over 2. Okay, so right away I have this term. I have it. Sine theta, it's x over 2. And theta is what? Is the arc sine of x over 2. Okay, so I have the theta I have, the sine theta I have. I just need the cos theta. I don't have it. Okay, so technically, you could just write here cos of arc sine of x over 2. You could do that. Okay, but that's not nice. Okay, let's do it more elegantly. So sine theta is x over 2. It means that if I had a triangle with a 90-degree here and an angle theta here, okay, so if the sine theta is x over 2, well, you know that the sine theta is opposite over hypotenuse. So if the opposite is x, the hypotenuse is 2. Okay, so this triangle really satisfies this relation. Okay, and so I could find now this side here using Pythagoras theorem. And so it's C2 minus B2 equals A2. So I will have the square roots of 4 minus x2. Okay, so we recognize that's what we started with. So it comes back again. Okay, and what were we looking for? We're looking for the cosine. So the cosine is adjacent over hypotenuse. So adjacent minus over hypotenuse 2. And now I have everything. I have my theta, I have my sine theta, and I have my cos theta.
Sure.
Yes?
Would it be wrong if we just like plug in arcsine x over 2 instead of theta?
It's not wrong, but that's not the way I want it. Okay? Cos of arcsine of x over 2, you have to write it to me in the nice expression. Like this. Okay? I don't want any arcsines, I don't want any angle, any trig in my answer. Okay? So I have 2, well, unless this one is the only one you have, the arcsine, you have no choice. Okay, so 2 arcsine x over 2, then plus 2 times sine, which is x over 2, times cos, which is root 4 minus x2 over 2 plus. And that's my answer. I'm just going to clean it up a bit. This is out. 2 arcsine x over 2 plus x root 4 minus x2 over 2 and plus c, and that's my answer.